Algebra 2, we are going to be covering a tougher section. It's lesson 90, graphing the tangent function. And so please take advantage of Desmos. You need to be able to do these graphs by hand, right? Because even looking at Desmos is going to take some work. But there is a little on your Desmos screen on the top right, there's a little tool that looks like a wrench. And that is how you can change Desmos from radians to degrees, but you can also alter your x-axes to show radians. There's a little word, if you click the wrench tool, look down where it says x-axis, and there's something called step, and you're basically telling it what its scale is. So you can set it for pi per box, or pi over 2, or pi over 4, or pi over 3. You know, it could be any of those. It could be pi over 6. It could be, you can set that step. So here is our tangent function. A, when we graph sine and cosine, is called amplitude, but that's not what it's called here, but it is part of our 3 fundamental points. B is our period. Remember, period means one full cycle, but in tangent, tangent has a standard period of 180 degrees. C is our horizontal shift, moving it left to right, and then D is our vertical shift. All right, so here we go. I'm going to graph the basic function. So I'm going to graph the parent function. So in this, remember my period will be 180 degrees. And so I'm going to show you what the tangent, now remember, review, tangent equals the tangent of theta equals the sine of theta over the cosine of theta. And so there are values where tangent is undefined, and that's where we're going to create these vertical asymptotes. In fact, on our unit circle, I have 1, 0, up here would be 0, 1, over here would be negative 1, 0, and down here would be 0, negative 1. All right, so for remember, sine is our y value and cosine is our x value. So any place that's going to be undefined would be at 90 and 270. And so these create undefined values, which creates asymptotes. So here is how we're going to set it up. And it might be helpful to have your unit circle nearby. All right, so if I say this is 1, 2, and so on, just so you can see what's going on. All right, so a full cycle is in 180 degrees, but it occurs over the origin. So this is pi over 2, which is also 90 degrees, okay? And over here would be negative pi over 2, or negative 90 degrees. So this would be, how did I label it? This would be pi. This would be 3 pi over 2. All right, so a period of 180. I'm going to, now remember, at 90 degrees and 270, tangent is undefined because I can't divide by 0. So that means I've got an asymptote here at 90 degrees and here at 270. The same is true for negative 90 and negative 270. So our graph, it looks very different. We're going to have one full cycle in each of these, and this section is 180, this is 180, this is 180, right? Because 90 plus 90, because the distance, it doesn't matter that this is negative, this distance between these two asymptotes is still 180. So because this is an invisible one, I'm going to start at 0, 0, right at the center, and then to the right is 45 degrees, and the tangent of 45 degrees is 1. And then from here down and over 1. And I'm going to set those 3 major points up in each section. So it's the middle. So, and you can use the unit circle at pi, it's 0, at, if I go right 1, up 1. So I'm going to draw this. This should confirm what you see in Desmos, where I'm going to connect and then approach my asymptotes. And so it's almost like a repeated cubic function. And so there's my graph. You can confirm this, but I have a full cycle. This is one full cycle, this little loop in 180 degrees. And then I have another one in 180, and then it will keep repeating every 180 degrees. So remember, if this is pi over 2, this is pi over 4. You'll be really good at fractions here. So we're going to graph several together. Our lesson practice is on page 632. So we're going to jump into part A, and I will go over how to graph them. So y equals 10 times the tangent of x. So nothing changes here. My period, I do have the 10 out here. That's going to affect where I put these first points. But it has not been shifted to the left or to the right, and my period is still pi. So I like to cut that in half, and so that'll be each side. And so I'm going to put my graph over here. I should have left myself more space, but oh well. So pi over 2, pi, 3 pi over 2, negative pi over 2, negative pi, negative 3 pi over 2. And so my asymptotes don't change. It's still undefined. Again, you can confirm this graph with Desmos. Okay, so the only difference, I still am going to start at 0. I'm going to start at the center in each of these. So since there's 4 boxes, right, I'm starting in the middle. But instead of to the right 1 and up 1, I have to go up 10. So I'm going to change my scale to be 2, 4, 6, 8. So 10 would be up there. 2, 4, 6, 8, 10. All right, so I got a point here at 10 and a point here at 10. And so instead of going to the right a box and up 1, I had to go up 10 because that's the effect of this guy. So my point is at 10. And so again, here would be to 10 and 10. So it just stretches our graph in between. Okay. All right, moving on. And I will save that page. So part B, they'd like us to graph y equals 8 times the tangent of x plus 4. So this is increases our points, right? Our points are up and down 8 units. This plus 4 means that our center was shifted up 4. But our period hasn't changed. So our period, because there's nothing inside here next to x, so our period is still pi or 180 degrees. Now notice I said my period is pi, but when I graph it, I space it out pi over 2 on each side, right? Because 1/2 plus 1/2 is 1 whole. So this graph is being shifted up 4 and then up to 8. So let's see here. I should probably move this down. So here's 4, 8, 12, and here's negative 4. My period hasn't changed, so pi over 2, pi, 3 pi over 2, negative pi over 2, negative pi, negative 3 pi over 2. Again, my period did not change, but my center, instead of being at 0, 0, is up at 4. So here's my center. And so there's a point here in the middle, a point here in the middle. Notice the center point is at 4. Okay? Now, from the center point, I'm going to go to the right one, but up 8. 2, 4, 6, 8. From here, over 1, but down 2, 4, 6, 8. And so this is that 8 refers to that first point that we graph. And so from this center to the right one, but up 2, 4, 6, 8. Back to the center, to the left 1, 2, 4, 6, 8. And it should confirm your points in Desmos. Whoops. I forgot to draw those points over here. So 2, 4, 6, 8. And last one, 2, 4, 6, 8, 2, 4, 6, 8. All right, next one, part C. So I'd like us to graph y equals the tangent of 6x. Now, that number in front of x is our period. So the 6 means that there are 6 full cycles in 180 degrees. Okay, this 1 means there's 1 full cycle in 180 degrees, so there's period is 180 degrees. But this one is saying there are 6 full cycles in 180 degrees. So to find my period, I take 180 divided by 6, or pi over 6. Either way, my period is pi over 6, or that is 30 degrees. So however you would like to look at it. So I need a full cycle in pi over 6 degrees. So the way I'm going to space this out, the way that made the most sense to me, because I need it to match on both sides. And this is, I need pi over 6. So what I did, I changed my spacing, okay? And that might confuse everyone. But if I need it to be 1 cycle and pi over 6, then this would be pi over 12. And this would be negative pi over 12. Because 1/12 plus 1/12 is 2/12, which is 1/6. And so there is my first asymptote. So if this is 1/12, this would be 2/12 or 1/6. This would be 3/12 or pi over 4. And this over here would be 5/12, which doesn't simplify. But I would have another asymptote at pi over 4 because that's 60 degrees. And so I've got another one here. So I kept the spacing the same on this one so that I wasn't having to redraw how I did this. So this is negative pi over 4. This is negative pi over 6, and so on. All right, so I have 2, negative 2, there's 4, and there's negative 4. So my center, this was not shifted in either direction, so my center is at 0, and I'm going right 1, up 1. So the only difference is my scale, because I'm going to have 6 cycles in 180 degrees. So I changed my scale to go by every 2 boxes is 1/12. You don't have to do that. It's really up to you how you change your scale and so forth. But there is that. We have 3 more to get lots of practice. Part D, y equals the tangent of 1/4 x. 3x. So this means there's only 1/4 of a full cycle in 180 degrees, or in pi radians. So I would have to actually divide 180 by 1/4, and that gives me 720 degrees. So my period is 720 degrees, or that would be 4 pi. Because each pi is 180, so there's 4 of them, so 4 pi. So the way that I'm going to spread this one out so that you can see that there's only 1/4 of a cycle in 180 degrees. Okay, so I'm going to do pi, 2 pi, 3 pi, 4 pi. Negative pi, negative 2 pi, negative 3 pi, negative 4 pi. And so on. So for me to have a full cycle of 4 pi, it would be 2 pi to the right and negative 2 pi to the left. So it's going to take a much bigger space to complete one cycle. So the next cycle is 4 pi away. So 2 plus 4 pi is all the way to 6 pi. And the same would be true here. So the center, this graph was not shifted up or down, so my center is at 0, 0. And the difference is I'm going to go to the right 1. I'm going to go to the right pi and up 1. So it should look like this. And you can check your work. The tangent of 1/4 times pi is, this is at 1, 3. This is at -1. This is at -3. So you can check Desmos for these points, but you're going to go to right pi and up 1, down 1 over pi. And so it's spaced out like this. But again, you can use Desmos to confirm. And that's what our graph looks like. Next one, I'm going to change. It's going to be different from the one in the book. So the tangent of 3x plus 5 equals y. So the 3 means there's 3 full cycles in 180 degrees. So 180 divided by 6, divided by 3 equals 60 degrees, or that would be pi over 3. So my period is pi over 3 radians, or 60 degrees. And this means that my center is up at 5. So a couple ways to do this one. I cut mine into thirds. I'm trying to find my ruler so that you can see this. And my center is up at 5. So I need 2, 4, 6. So my center, I know, is at 5. But my cycle is 60 degrees, so I'm going to go 30 and -30. So there is one full cycle. Because 30 plus 30 is 60 degrees. 30 degrees is also pi over 6. Okay, so this next box would be pi over 3. This next box, so 1/6, 2/6, this is 3/6, so pi over 2. 4/6, 5/6, 3, 4, 5. This would be pi. And so I'm going to go the same here. If this is pi over 6, 1/6, 2/6, 3/6, so this is negative pi over 2. 4, 5, 6, 6 would be 1. So I have an asymptote. I have a full cycle every 60 degrees. And my center is at 5. So on this one, I would go over 15 degrees and up 1. So I'm going over half and down so I'm going over 15 degrees and up 1 in each direction because I have, 3 full cycles in 180 degrees. So, for example, from negative 30 to 150, that's 3 full cycles in 180 degrees. That's what that 3 means. And you can confirm my points using Desmos, but I would put your scale into sixths. All right, last one. Has several parts. So the last one is f, y equals 2 times the tangent of x minus pi over 3. So this means that my graph has been shifted to the right, pi over 3. And then this here, right, affects from the center up and down 2. My period, though, there's an invisible 1 right here. So my period is just the standard 180 degrees. Now this one's going to be a little complicated, so I am going to be using a pencil because I'm going to show you how I'm going to shift this to the right. Okay, so I'm going to do, this would be pi over 3, so this would be 2/3, so this would be pi, this would be 2 pi. So each box is 1/3 pi. And I did that because I am going to have to shift it. And so then this is 2, 4, -2, -4. All right, so the easiest way to do this is I'm going to use a pencil. If I was to graph this, my original asymptotes would be at pi over 2, which would be halfway, so 1.5 boxes to the left and to the right. And then in the middle of these two would be 1.5. So those are the original asymptotes. But my whole graph, so here's my original point at 0, 0, is being shifted to the right pi over 3. So that is shifting everything 1 box to the right. And so I'm going to draw my actual asymptotes, 1 box, which would be halfway past -pi. It'd be halfway to the left of the origin. It'd be halfway or half a box before pi, and it would be right here. Whoops, nope. Sorry, I'm shifting everything 1 box. I only shifted that 1/2. These take a lot of thought, so don't feel bad if they're difficult. I have to erase and start my graphs several times usually. So everything got shifted 1 box over. So this center would be here. I'm looking for the perfect center between each one, and I would go up 2 units. So right 1, right 1 up 2, left 1 down 2, right 1 up 2, left 1 down 2. And there is my graph. Whew. And it would keep repeating itself, but that is the basic. You don't have to do a million of them. So the homework for 91, you're going to skip numbers 7, 14, 15, 28, and 29.